So this conference, one of the themes or the theme is how businesses and society could adapt to climate change. And one way to adapt is to change the distribution of the sources for our electricity. And I'm going to focus on one source, particularly solar, and particularly solar residential. What I'm going to do is to start by documenting the trends we're seeing in growth in system installations over time. And then I'm going to think about why we might be seeing those patterns by looking at several costs and benefits to see if those factors matter in individuals' decisions. And then finally, I'm going to look at factors beyond economic costs and benefits, such as learning and information about local weather and the influence of peers. So first, why should we care about solar? Well, solar is a small but growing source of electricity in the US. About 3% of net electricity generation in the US in the most recent data from September of this year came from solar energy. That figure is about 20% in California. Also, solar is a policy priority at the state and the national level. In the state, we have SB 100, which basically has the goal that 100% of total retail electricity sales in California should come from renewable or carbon zero sources by December of 2045. Also, California has a solar mandate, so with some exemptions and carve-outs, and other details, new residential construction is required to have solar panels for electricity generation. At the national level, the incoming Biden administration has indicated that electricity generation from zero carbon sources is a policy goal. So it helps to understand the forces behind the decision to install solar panels. So for some perspective, let's look at the big picture. This is showing you electricity generation at sort of total installed capacity. So the amount of electricity that can be generated by the installed solar panels in the US. For a couple of different sectors, the lighter blue color, that's utility scale, and that swamps the other two, non-residential and residential, which makes sense. Utility scale is called utility scale for a reason, but what we see is that residential is non-trivial. So residential is the darker blue color, and that's what I'm going to focus on here today. So for a little bit more detail, this is showing you the number of new solar panel system installations in the residential segment each year. So this is the number of installations, not the capacity, not the electricity that could be produced. And you can see that there's been substantial growth over time. Now, I do want to note that we see a drop-off in 2017 and 2018 relative to 2016. And this could be because some of the major solar panel system incentive programs have ramped down and ended recently. Also, the 2019 data just came out, and the 2019 numbers show a bump up relative to 2018. So that's useful information as well. I'm going to focus on photovoltaic electricity generation, so not utility scale and not solar for thermal heating like you might use to heat a pool. When economists are thinking about a decision, we like to talk in terms of costs and benefits. So let's look at some of those now. Here we see a major cost involved in the decision to install solar panel systems. This is the price people pay for the system and the installation, and this has come down over time. At the same time, though, and I mentioned this before, upfront rebates and grants have gone in the other direction as major incentive programs have ended. And the end of these programs could explain why we saw fewer new system installations in the residential segment in 2017 and 18 relative to previous years. Looking at the benefit side, better technology, more efficient panels have people have seen more efficient panels, so the technology has gotten better. Also, the price of a substitute good, that would be electricity from the grid, that has gone up. And generally, we would expect that when the price of a substitute good goes up, that we should see more demand for solar panel systems. There are a number of other factors which could matter as well, and that includes some payment methods or sort of incentive methods like net metering and power purchase agreements. Those could matter as well, but the factors that I showed you are some of the major drivers of costs and benefits. Before I put all this together into a model to explain installations, it's helpful to account for variation not across time, but across space. And that's what you're seeing here. This is a measure of how suitable a local area is for solar electricity generation from solar panels, where the darker red colors indicate that there's more potential energy that could be generated by residential solar panels. Those are the darker red areas. And the lighter colored areas indicate areas that are less suitable, so there's less potential energy that could be converted into electricity. And the takeaway is that areas in the southwest of the state generally have more solar potential than in the northeast, and that's not terribly surprising. So now let's put all of this together. And I want to build a predictive model of solar panel system installations. And the goal is to quantify the patterns in the relationships we've seen in the prior charts. So I want a way to explain new installations in a given county in the US in a given month. And I'm going to use average solar radiation. So that captures how suitable a county's local climatic conditions are. So think about the map I just showed you. Also going to use residential electricity prices, the cost to install panels, panel efficiency, upfront grants and rebates, and another set of variables called state by month fixed effects. You can think of these as state-specific seasonal adjustment factors. Looking at the results, the signs of the coefficients generally fall in line with what we predict. So I'm going to focus on a few, and the few that I'm going to focus on are ones where we might have some policy control. So first, let's talk about residential electricity prices. The relationship you see is positive, as you would expect, where the price of substitute good of residential electricity prices from the grid, when that price goes up, we should expect to see more demand for residential solar panels. And in terms of the magnitude, the finding is that when residential electricity prices go up by 1 cent per kilowatt hour, that tends to be associated with about 18 more installations. So for some perspective, because that number sort of comes out of nowhere, across all counties and months, the median number of installations is about 9 per month per county. And also the average year-to-year change in residential electricity prices across the US is about 25 cents. So these changes are not, given the coefficients, are not something that we would not expect to see in a reasonable amount of time. So their magnitudes are quite reasonable in terms of perspective. Next, what about the cost to install? So this relationship is negative as expected. When prices drop, you expect to see more installations. The magnitude here is that when costs decline by $1 per watt, so $1 per unit of electricity that could be produced, we tend to see about 12 more installations. And again, for some perspective, the average year-to-year change in costs is about 30 cents per watt. I briefly want to comment on upfront grants and rebates. The predicted relationship is positive, so more grants and rebates should encourage solar panel, or one would predict would encourage solar panel installations, but this is not what I find. I don't find any statistically significant effect. And this could be because grants and rebates have been falling over time as the popularity of solar panel systems in the residential sector rose, so it might be difficult to disentangle that true relationship from overall temporal patterns. It could also be that there were a lot of early adopters and still have been a lot of early adopters, people who are maybe less sensitive to grants and rebates and would have installed solar panel systems regardless of any government support. But the key takeaway is that drivers of economic costs and benefits for the most part matter in predicted ways, though nature, if you look at solar panel or solar radiation, also has explanatory power in this model. Moving on, what else could matter? One thing is that individuals' own learning or information gathering and observations about their local weather in their area. So think about very sunny and warm days relative to very cloudy and cold days could matter. There's some recent research that finds that people's choices are in fact influenced by very recent weather patterns. So to test this, I add a measure of solar radiation relative to what's normal for that time of the year in the current month, and also last month back to 6 months ago. When I add these variables in, I don't find any statistically significant effect of recent weather on the decision to install a solar panel system. Continuing with what else could matter. Friends and family could provide information or ideas or encouragement. There could also be a kind of copycat behavior going on where you see your friends and family making a decision and then you decide that that decision might make sense for you too. Economics is full of papers trying to estimate what are called peer effects, how much peers affect what you do. So the way I'll measure that in this case is to use data provided by Facebook called the Social Connectedness Index. This is a measure of friendship links between pairs of counties in the US, where the more friend links there are between two counties, the larger the value of the index. So what I do is I calculate an average number of installations in connected counties where friends are located, and I weight this average by the strength of connectedness. So let me give an example. Let's say we have one county, this Gold County, and people in this Gold County have friends in two other counties, the Purple County and the Green County. Between the Gold and the Purple County, the measure of connectedness is 5, and there are 10 installations. Between the Gold and the Green County, the measure of connectedness is 15, and there are 4 installations. So then the friend-weighted average number of installations is 1/4 times 10 plus 3/4 times 4, and that gives you 5.5. So this is a completely hypothetical example just to help you understand the variable that I add into this model. And when I do that, and I also add some lags of this friend-weighted average, I find that generally, if the friend-weighted average number of solar installations increases by 1 in the current month, then there tend to be more installations in your own county in that same month. And if you look at the coefficients on the lag, so the friend-weighted average this month, last month, 2 months ago, et cetera, you find that that coefficient is smaller for 2 months ago or for 1 month ago and smaller still for 2 months ago. So one story that's consistent with this pattern of coefficient decay is that people are swayed by the ideas and conversations they have with their friends rather than trying to imitate what they see their friends doing. If imitation were the main story, then we'd expect lags to make more of a difference than what's going on contemporaneously. Before I get too far, I do want to point out that an alternative interpretation, which is one that I cannot rule out one way or another with the data I have, is that what's going on is that friends tend to be friends with people who share some feature in common. So that like-minded people might independently and spontaneously just decide to do the same thing at the same time, meaning that the results would have nothing to do with the idea flow between friends and more to do with the fact that friends are similar and similar people might make the same decision at the same time. And I can't rule out which story, this story about friends being similar or the story about information flow, is what's really going on in this situation. So keeping that caveat in mind, what does this all mean? For policy, if the goal is to encourage more installations, improving technology and lowering costs will probably help. Also, again, keeping the caveat in mind, there could be a virtuous cycle where promoting solar in one area could lead to more solar panel system installations in another area through networks of friends. So with that, that is what I have to present to you today about solar panel installations.